When I did the design for this thing, I was remembering an old Motorola TV, and it had this expression of works in a drawer, kind of like this.
Quasar Color TV System, based on a big idea in color TV. The works in a drawer TV for ease of service. We think it's a better way to build color TV because the modules can be plugged in and out right up front. Get ease of service plus the advances in our solid state chassis design.
One of the things about it was you had this drawer and you could pull the drawer out and you can get to all the modules and make changes and adjustments very easy. In its day, it was like, big deal. So I figured when I built this mill, I would do the same kind of thing. Put everything in a drawer. I could pull it out and I could get to everything. So that's what I did. And I'll tell you what, it's really handy. If you design your own, steal that idea. It's a good one. So I've got it torn down a little bit. Sometimes you have to tear down to make it better. Decided to replace the front cover on here. A lot more air holes for air to come in. And what I'm going to do, or what I'm going to try to do, is I've got two fans now. I'm going to have them force air in. Now some of it obviously is going to blow out here, but it's going to pressurize the bay. And here, here, and here I have holes underneath. See? So my thought being that it gets pressurized, some of the air would go down through there and exit these holes in the bottom. Give me a little bit better ventilation on these. Yeah, while I was doing this, I got kind of bored. Went outside with some expanded PVC and I drew up a fan cover. Nice little 3D model. Made a couple of them and painted them, and I got to get the right size screws, but they're going to go on there. I think that's going to look nice, and that wasn't all the way dry. Okay, so now it's got a fingerprint on it. Oh well. Been doing wiring, and I got to do a lot of splices and come up with, how to get the wire run out to here and make it all to where you can actually open the drawer and modify it and whatever, and then close the drawer. So, whew, crazy. Marshall said that this plate here is too small because it's only got 3 wheels on it, and he's afraid that this thing could move side to side. And he's built this one here, which has a huge plate on it with 8 wheels, and the anti-backlash nut is up on the top. And I made the mistake of saying, that's really cool. I like the way you did that. So he's like, well, we're going to make another one. So off we go. You're putting some T-nuts in?
Yes.
And okay, you're going to bolt it right down to the plate, huh?
Yeah, it should have a piece of plastic under this, but I've already messed it up enough.
Yeah. That is what, 1/4 inch thick plate, huh?
Yep.
That's pretty awesome.
Yeah, measure 6.6.
Yeah, I'm used to doing that with my big 3,500 pound machine, but I didn't think a little machine like this would be able to handle that. That's pretty awesome. And judging from the cuts on here, it does a pretty good job.
It made all these plates.
Wow, cool.
Well, a worse machine made all those plates.
So Marshall made a new plate, and this is the magnet built right into the plate. That's a beefy plate. It's 8 wheels, all of them with offset cams to be able to be locked down into place. Can actually take a spindle twice the size of what I've got. Not that we'd ever put one that big, but it could do it. Yeah, go ahead. Yeah, see, we could, it would accept one that big, which is like, by comparison to that. Yeah. Yeah, yeah, look at it, look at the difference. Yeah, not gonna happen, dude, not gonna happen. And that'd be like way overkill. As you can see, messy desk. It's always a messy desk. But anyway, as you can see, I've got this all wired up. And I wanted to get back on the whole Frankenlabs train and kind of show you guys what's going on. I've got my X, Y, and Z, actually X, Y, and Z units loaded in. And all this wiring looks super complicated, but it's not really. In here you've got a connector for each one of these. These are stepper drivers. You set the switches in here to kind of tell it what kind of power settings and stuff, and that's all down here in this little thing. Alright, over here I've got my home switches for X, Y, and Z, and I've got an extra one that'll be used for the probe at some point in time, and then these are all the common grounds. Signal from the PC, 5 volts to make it all work. In the back I've got the spindle driver. It's got 2 inputs for pulse width modulation, which is a little board here. It takes 12 volts from here, and the pulse width modulation comes in. This thing does its little magic and sends out an analog signal. That's the whole thing. Works in a drawer, and it works pretty well. This week I'm out in Arizona tooling around the desert doing some survey work. Unfortunately, I won't be able to get back for another week to get the next in the series for this video going. But as you can see, we've got the whole works in a drawer set up, and it's operating great. I mean, if you build one of these machines, you really need to do it that way. You can access everything. So the next video, I'm going to undo all of the settings, and we'll start from scratch. We'll go through and do all of the settings, and I'll show you how to get the motors operating and get all of the calibrations and everything like that done, so that if you're building a mill, you'll be able to follow along and get your mill operating properly. Also, leave me some comments. Let me know what you think. Do you like the videos? Not? Am I going into too much detail? Not enough? Let me know, and I'll tailor it a little bit and try and make it a little bit more enjoyable. And we'll both learn a little more about CNC. So I'll see you on the next video, and thanks for watching. So here we are at yet another site doing another survey. Keeping me out of trouble, man. Keeping me out of trouble.